Good day, everyone. Let me take you through the statistical analysis we performed on our employee dataset, specifically focusing on the ages of employees. The goal here was to explore and understand the age distribution in our workforce using various statistical tools. We started with range, which is the simplest measure of variability. It tells us the gap between the youngest and oldest employees, giving a basic sense of how spread out the ages are. Next, we grouped ages into intervals to create a frequency distribution, showing how many employees fall into each group. To make this easier to visualize, we plotted a histogram, a bar chart where each bar represents an age group. This helped us quickly see which age groups are most or least common. To highlight trends, we connected the midpoints of the histogram bars with a line to create a frequency polygon. We also made a cumulative frequency polygon to show the running total of employees, which answers questions like how many employees are younger than 40. For summary statistics, we calculated central tendency measures like the mean, the average age, the median, the middle value, useful for identifying typical employees without outliers, the mode, showing the most common age. We also explored quartiles, deciles, and percentiles. Quartiles divide the data into 4 equal parts, identifying benchmarks like the youngest 25% or the middle 50%. Deciles divide the data into 10 equal parts for finer segmentation, such as the top 10% of employees by age. Percentiles divide the data into 100 parts, providing precise thresholds. For instance, the 90th percentile shows the age below which 90% of employees fall. We then explored dispersion measures like variance and standard deviation, which indicate how much the ages vary around the mean. These were complemented by shape measures such as skewness to see if data leans towards younger or older ages, and kurtosis to check if the distribution is flat or has heavy tails. Now let's talk about moments, which give us a deeper understanding of the data's shape. Moments about the mean. These describe how data is distributed around the mean. For example, the second moment is the variance, which measures how spread out the data is. Moments about arbitrary origin. These are calculated relative to a chosen point, providing flexibility in analyzing data from any reference point. Moments about the origin. These raw moments measure the general shape and are fundamental for calculating higher order characteristics like skewness and kurtosis. Moment ratios. These ratios, like skewness, third moment ratio, and kurtosis, fourth moment ratio, help summarize data's symmetry and peakedness. All of this was implemented using Python libraries like NumPy, Pandas, and Matplotlib. These insights not only summarize our workforce's age distribution, but also lay the groundwork for strategic decisions like recruitment planning or retirement forecasting. Conclusion. This analysis provided valuable insights into the age distribution of our workforce. By combining measures of central tendency, dispersion, and data shape, we've identified key trends and benchmarks. These findings support informed decision-making for workforce planning and strategy. I'm happy to dive deeper into any of these points if you have questions.